Hi everyone, my name is Idris Olubisi. I am a software engineer and a technical writer. I currently work as developer relations engineer at Mara. Today I'll be speaking about building decentralized application on the blockchain and deploying it to testnet. So we'll be doing this using building smart contracts on our Visual Studio Code and also deploying the smart contract. We followed some steps and processes that's required for building and deploying a smart contract into testnet environment on the blockchain.
So to start with, what is a blockchain? So basically blockchain is a distributed database. I would see it as a collection of data, something that actually stores data for you with encryption, with some sort of encryptions, and which does not allow it to be mutated. So which means that whatsoever is being encrypted or stored on the blockchain cannot be updated or modified. So you could regard blockchain itself as a distributed ledger technology. They are something like, we have like ownership that's been attached to blockchain itself. So it comes with, that's when you see people with wallet address, where you have the public key, you have the private key. Private key actually signifies that you are the owner of that public key. So the cryptographic part of it is that it's encrypted in such a way that the private key is attached to a public key. Public key can be shared to anyone to receive. So for you to receive funds, receive whatsoever, but private key is for you alone, which is always advised to keep. That's like a behind the scene on the blockchain. Blockchain uses your public key to get your private key to know who is actually sending that data on the blockchain. So let's talk about how the blockchain works, like in steps where you could also like understand what happens behind the scene on the blockchain. First, a transaction is entered by an authorized participant and must be authenticated by the technology. So, which is the similar thing I just mentioned earlier, where you authorize, as somebody authorizing a transaction means that you are the person sending that transaction into the blockchain itself. So it could be, we have so many decentralized applications now. We have so many exchanges. What they are doing on your behalf is to give you a platform that you can interact with. And because you have connected your wallet, you are the one requesting that access. Like I said earlier, that encryption happens between the public and the private key. So, which means that authorizing with my public key, the system can detect my private key and know that, hey, this is the person that's actually deploying this. So it's more or less authorizing me on the chain. A block represents a specific transaction or a data created. So on the blockchain, like the name implies, blockchain, we have series of blocks, series of nodes across. So these nodes, see them as servers that is distributed across the world. And as of today, we have thousands of servers that's already been deployed and available for anyone. So those servers, we have like miners that owns those servers. What they do basically is to verify each block or each transaction going into a block. So after that is being verified, we have like ways where they get rewarded. You might, I don't want to go into those proof of work and proof of stakes, but it basically means that they have a way of rewarding the miners for providing those servers and allowing them. So, and due to the encryption and the proof of work and some of the activities they will need to do, it's somehow being verified before they finally allow any transaction to be added to a block. And blockchain, we have lots of blocks that are interconnected together. So the next one is that the block is distributed throughout the network compute node. So now, just like the previous step, I mentioned we have several nodes. So the first one by entering, authorizing the participant. The next thing the system does is the block itself represents the transaction of the data, and the block is distributed throughout the network of the node, where I mentioned the miners and people that are involved or people that owns those nodes that are interconnected. Yes, so the fourth step is after the transaction is being verified by the miner. So authorized nodes append those blocks to the current blockchain. And the miner nodes network, they are primarily just compensated with work, and it's through like proof of work or proof of stake. So proof of work is just like Bitcoin and Ethereum uses proof of work, where you get to do some work. So the work includes, you might be wondering what kind of activities is required for a miner. So there's something called the hashing, that you need to find a nuance, like hashing algorithm in such a way that a number or a particular alphabet will be missing from an algorithm. Then you kind of decrypt it. So decrypting means that you're putting in some work. So there are several machines computed or like interconnected for you to do the work. So the proof of work there is that that particular node or machines would be like creating algorithms to find the missing letter. So doing that, it requires some machines, some infrastructure to be set up, and yeah. So that way you could decrypt. So the first person to decrypt gets verified, and they get rewarded for that particular decryption. And others, if others gets to decrypt it, there's something called uncle block. Uncle block are the ones that are already like available, while a lot of people decrypt it, but this person decrypts this particular problem, or let me say the algorithm for that particular transaction. The person gets rewarded for that. And the final one is, so the update is propagated through the network, completing the transaction. So propagation means that, these nodes, they are peer-to-peer interconnected together. So peer-to-peer in this case means that we might have, like, let's say series A. Okay, yeah, let's say this first row, there are nodes that are interconnected. And the second row also are nodes that are interconnected. So now, if any new transaction is coming in and it's verified by any of the nodes or like the miners, it gets added to the block. And once it gets added to one block, every other block gets a copy of that particular transaction. That's why it's very difficult. What is required for you to just get that transaction into a single block? Every other block connected in the peer, in that same peer, they get updated with the new transaction that has been added. So there's no way you can wrongly, if you wrongly had a transaction or trying to manipulate a transaction, it means that all other nodes won't have the new copy that you just added because it's not verified. And there are consequences like for that. There are cases where you get kicked out, that particular miner gets kicked out and gets banned forever, not being able to verify any transaction again due to that fraudulent or kind of suspicious activities trying to manipulate the record there. So now, I just mentioned like this row, which is just 5 nodes, and the next row. So imagine we have thousands, we have like about hundreds of nodes, and we have different peer-to-peer. So it means that if we have 100,000 nodes here, that's like peer 1, we have peer 2, peer 3, like that. So it's very difficult. Once a transaction gets added to a single node, all other node gets propagated, and that's after verifying that that transaction is correct and genuine. So that's like how the blockchain, so it might really sound somehow, but the idea behind it is just to see it as something that keeps track of something, like keeps track of data, and it's pretty much secured because of the crypto hashing, cryptography rather, the hashing that is required for every transaction. So now, let's talk about smart contracts. So how does smart contract come to play? So smart contracts are basically, how do you get to interact with the blockchain? So now we know the blockchain saves data. It stores data, uses crypto hashing. It has some highly configured like security stuff like that. But what is smart contract itself? So smart contract is a self-executing contract which serves like a terms of agreement between buyer and seller. And also, by just that agreement is by just writing a line of code, and what it does is, if that particular code or action is required to pay somebody September 5, once it's September 5, the payment would go out. That's after the smart contract has been deployed. Nobody can stop it. Nobody can mutate it. No, even the deployer. That's to get to that extent that even the person that deployed the smart contract, that wrote the code, cannot update that particular activity again. September 5, the payment gets out. Nobody would stop it. So it means that if we, as a buyer and seller, we have agreement to get paid, or maybe for a freelancing project, there's a certain percentage or at any point that we need to have like a payment being sent across. once we kind of deploy a smart contract to handle that, when it's that time, it will definitely go out. So just see smart contract as something that interacts with the blockchain and also keep agreements distributed across the decentralized environment, which is, of course, the blockchain technology. So now, we understand what blockchain is and what the smart contract is to blockchain. So how can we build, these things are like, they are not public facing. Even if they are public facing, they are just strings of data. We don't know how can we interact with them. So we have the Web3 stack itself. Like the Web3 stack means that some of the things that we already have out there that you can leverage on as a developer. The Web3 space is a growing space. We have like a lot of things coming up as we move, but there are like certain stack for you to follow up, coming from the background of Web2 or a complete beginner or somebody that is crypto or Web3 enthusiast. So we have the protocol layer, which is the one we currently have underneath. This is like a layer 1. This is the layer that you would, for example, like Bitcoin, Ethereum, they are layer 1. We have Cosmos, Avalanche, which are like new. They are not really new, but they are kind of solving the problem in a different way. They are like layer 1 blockchain that you could leverage on to build on. So they have all of these algorithms in place. What you just need to do, interact with them using smart contracts and get to deploy your application, leveraging on those blockchains. That's the layer 1 blockchain. Now, moving up a little bit, we have the infrastructure and category stack. So this is where you come across like Open Zeppelin. Open Zeppelin is just like I would say a security protocol layer for smart contracts. So they are open source. You often see their packages available. So, there are standards to every thing we do in tech. There are people governing that. And we have tools that has been rolled out to just make our lives easier. And things like leveraging on Open Zeppelin, Cetric, it could really help you to, just use one of their packages and you're good to go, and which is highly secure. And we have storage system like Airwave, IPFS, Filecoin, where you could store your data online. And this is not storing this data on a centralized server. It's actually storing the data on a decentralized server. So the difference is that the centralized server could wake up one day and say, hey, we can't find your data, we are sorry. Or they said, you need to pay more to get access to your data. But for a decentralized protocol, because those data are actually on nodes across the world, because just one copy, trying to upload your data online means that, like we explained earlier, where you get your transaction signed, and all other nodes get a copy of that particular transaction, which means that your server, your files, your images, your video are always available on all of those nodes anytime you need them. So we have analysis also. We have communication, where you can use matrix, swarm. There are a lot of cool stuff, but I don't want to bother you with a lot of things. And we have identity, the ENS. I don't know if anyone has heard about ENS. Just like you can get a domain name on ENS. Instead of the public, if you create a wallet, you get assigned a public key, which is like a very random string like that. So ENS, what ENS would do for you is to just connect, give you you can customize your domain, say idris.ens, which means that idris.ens can be connected to my public address. And if you want to send me fund or want to transact or send anything to me via my address, I can easily give you idris.ens and I would get to receive that in my wallet. So, yes, we have the transaction layer where you have buy and sell, like Uniswap, PancakeSwap, all of these platform that does crypto exchanges platform. So we have a lot of them ideally. So another use case layer is the gaming part, where we have a lot of people leveraging on the blockchain technology for you to know how powerful it is to build on the blockchain. The gaming industry also find a way to see how they could actually leverage on the blockchain technology, while people are playing games, maybe when it gets to rewarding them, they get rewarded via the blockchain. That's the blockchain itself, giving them like coins or tokens to reward them. And also, we have the NFT platform like OpenSea, Rarible, where you can easily, upload your NFT, or that's your images, and as non-fungible tokens where you can sell it off and, make cool money. So we have aggregators, we have Daprada, where you can, do some DeFi stuff. We have Zappa, we have the Web2 space itself. So Web2, like the social media platform that you might have seen, like Web2, Twitter, Instagram, and the likes, they're like a good example of Web2 applications. They fall in that access layer category. We have like platforms like a lot of platforms that would serve as an intermediary for you to do like RPC calls, which is remote protocol calls, to all of this chain using those smart contracts. Those people just give you like a platform to easily interact with them, because ideally, if you have to set up your own node and interact, it costs more, it costs a lot to set up, and just like Bitcoin does not, you can't have like, you can't build on Bitcoin as of today. So I think that's when Web 5 came in, something like that. So it's Ethereum that allows you to interact with the chain using smart contracts. So another advantage is that it has high speed of execution. All of this work, you can have a lot of work, but what matters when building smart contracts is how the logic is, because at some point, if you have too many logic, when you want to deploy, that particular smart contract uses a lot of gas. A lot of gas in this case means that a lot of fee to deploy, because there's a lot of things. So that's why we have like smart contract auditing, security, to see performance, to see how things is like, to test things out before you deploy them, and just to ensure that you don't have like a loop that keep running forever, because you don't just want to waste people's time. All right, so for things to be like very easy for us to follow through, I created like this gist for us to follow through. So if we have like our system up, we can start the process right now. Like I said, this is like the series 1, and in this particular demo, we'll be building a DeFi smart contract, similar to what Buy Me a Coffee. I don't know. Is anyone, do anyone know Buy Me a Coffee? So what Buy Me a Coffee does is that like people get to, once you create that particular account, people get to like tip you for any funds they send you directly. So now Buy Me a Coffee is a Web2 app, but now we are building it in Web3, where you don't need to go through anyone. People can just, even you yourself, you could build your own platform, style it the way you want it, build your smart contract and deploy it. As an individual, I can share you that link for you to send me funds if you want to, like for coffee or for anything that I need, or you just want to give me something or a tip. So the first step we're doing now is to ensure that we have Node installed on our PC. Yeah, this is the step 2. What it does is to, like, if you run this following this command, the first one, what it does to skip the several questions being asked by NPN, and by adding the -y, is actually initializing an NPN project. Okay, yeah, so to ask you like a couple of things. The first one is just select a JavaScript project, then accept all other requests. Just keep pressing enter, enter, enter to accept all other requests. So what it does is just for us to spin up a JavaScript compatible running environment that can be easily used to build a smart contract and compile it, test it, and deploy. Smart contract comes with a native built-in payment system, which, for example, the EVM compatible uses ETHARs, so it helps you install all of that. But should in case it doesn't install, you can just easily copy this and install it. So now, creating this basic coffee portal now, we can now proceed to navigate to our test folder. Create a new file called coffee-test.js. If you are familiar with coding before, or like writing tests, even if we are not, this is basically for, we're using the child package. So we've already installed it while we were installing, like running the nps adapt command. It has installed this text package, the chai, for us to make use of. So you can easily use describe, then name the test as coffee portal. Then it should means that this particular contract that we are deploying, we should be able to deploy it. So we are validating, because this is a test. We are testing that we should be able to deploy this particular contract. And it is very important that for every smart contract we write, we should be able to test them. Like, test is very important. We don't want to deploy something that will fail in production. And you know, anything you are working on or deploying on mainnet, it requires funds. Which means that if you deploy wrongly or you don't test properly and deploy your smart contract, you lose funds for deployment and your contract becomes useless, because you have to compile and deploy another one. So it takes time to build. It also takes extra time to test. And also another time to audit that smart contract and ensure that it conforms to all of these standards that is required, and it doesn't have loopholes for, you know, hijackers or, you know, hackers to take advantage of. We are just basically tell that we initiated a variable called coffee portal. You can copy this right here on the GitHub gist into your code editor. So we initialize it and await. We try to make a request. So connecting to this, if you notice, we have await ethers.get contract factory. So this get contract factory, what it does is that it kind of retrieve our contract for us using the name. So retrieving the contract now means that we can have access to the contract name itself, and the next line deploys it. So you might be wondering, the ethers.js, like, we didn't define ethers anywhere in our test file, and we are using it. This is because Hardhat has already installed it behind the scene, and because you know that Hardhat creates like a runtime environment for you to be able to use JavaScript packages to compile and deploy smart contracts. So it does like all of those things behind it. So what you need to do is just request for that particular package you are looking for and make use of it without specifically like stating it clearly or importing it independently. So now the last line there is that we expect the test, the coffee, because after deployment of a contract, like I said, the blockchain keeps track of like the account that deploys that contract. So now from the contract deploy, we are validating and testing that it returns an address. And this address is expected to be a string, which is regarded to as our public key. So this is like the basic test that we're currently doing. Before step 4, after this step, if you run that same command you ran before, which is npm hard test, you should be able to see this particular test passing. You can confirm that by running npx hard test. This test would run, and you will see the success for this particular test suite passing. So before we now proceed, so we've written like a very starter code for our smart contract, and also we've written a test to test that particular smart contract. So now the next step is for us to deploy it. So deploying means now we're deploying it, but we're utilizing the local environment. So what we are doing specifically is to create like a node, like simulate how the blockchain works and run the blockchain on our PC. That's what we are basically doing. So now inside the script folder, you can create like a deploy.js file, then add this following code here. So what this code does is that it helps us deploy our blockchain, our smart contract, to a local blockchain that's running on our system. Yes. So after copying this code here, what this code does is that if you check the line 1, it talks about extracting deployer from the get signer. So running your local node, there are some accounts that will be generated for you. They are free accounts. It will generate, the public address will be generated, and the private key will be generated on your console. That's like the next step that we are doing now. So what we are trying to do is to get a deployer, the account that is being used to deploy that particular smart contract. Then we try to get the account balance of that particular account. then we deploy the contract. So the part where we deploy the contract, we're only doing the same thing we did while we wanted to test it out by getting the contract name and deploying it. Then are waiting for the contract to deploy. Then after that, like after copying this section, we can easily paste it into our deploy.js, then follow through by running npx hard node on a different terminal. What hard does behind the scene for you is that npx hard imports all of the file that is required for compiling and deploying your smart contract. So you come across like a lot of files that ideally Visual Studio Code or compilation is meant to return module not found or package not defined or something not defined. But because ADAT already installed all of those things behind the scene for us, and remember that it's like a runtime environment for JS to compile your smart contract and help you deploy them. So it has installed all of these things for you by default. So all you need to do is to just get access to it and deploy it, and you're good to go. So now this is the step we'll be running now. You run npx hard node in a on a different terminal, that's in a separate terminal, and you run the next one, which is npx hard run script -deploy.js. If you notice, that command line comes with -- network localhost. So it means that the first command there is npx hard node, which means that we are spinning up blockchain on our local system. So when you run that command, you see like lots of address and their private key printed on the terminal. So that means that we can utilize all of those accounts by default whenever we deploy our blockchain or you try to interact or make some interaction with our blockchain locally. So we are specifying that network on the second line, saying that we want to deploy whatsoever that is inside deploy.js, but using the localhost network. That's localhost network in this case, like the blockchain node that we are running locally. Then add the following code snippet. So what this code snippet does is that we are initializing 3 different accounts from our get signers. The default one is the owner. The second one is the giver, that's any other person. And the third one is the giver too. So now what we are doing here basically is that we want to test that particular, we want to have interaction with that contract that we deployed. This is not the test using the test package too. This is like a test as if we have our front end in place and we want to interact with this particular smart contract. So what we are doing basically is to initialize, get the contract factory, deploy it. After deploying it, await it to deploy because it's an asynchronous task. Then after it's been deployed, we are logging the address. Then the next thing we are doing is to get the balance of the owner. So this is just to be sure that everything is working fine. We want to get the balance before we buy a coffee. Then get the balance after the coffee has been bought. So we could kind of compare the difference and what we have before somebody sends us a coffee and what we have afterwards. So yeah, this is basically what we are doing. The first person is buying coffee. The second person, Clayton, is buying coffee. Jordan is buying coffee. And now, we now are waiting to get all of the coffee. So if you paste this particular code snippet into the coffee.js file under the script folder, you should have a lot of things logged on your console when you run the command we ran earlier. You can name it deploy.js, you can, but the good thing is that always separate your deploy file from your test file. So now we have the deploy.js inside the script folder already. You are creating coffee.js there to interact with your smart contract. It doesn't mean that you want to use it to deploy your smart contract. So you have a file that could deploy your smart contract. You have the one that you can use to interact with it, even without doing any front end. So you can understand how your smart contract works, the response, and what is required for you to interact with it. So after that, after running that command, you get series of logs, which shows your the coffee that was bought, the balance before buying the coffee, then the balance after buying the coffee. So yeah, I think that's all. We are good to go. But the next thing now is, we deployed our smart contract, which is like too technical and code focused. So we'd have like a front end built with React.js, where we can interact with our smart contracts, and that will be happening in our series 2 of this Mara Blockchain Masterclass. We'll be deploying a front-end application and also interacting with our deployed smart contract. So that way you get to understand how to even connect to a smart contract from a React application using the API generated after deploying a smart contract. So that's the next thing, building a decentralized application. So we have platforms that could allow you to even build and deploy. The generic way of deploying React.js app is maybe Vercel, Netlify, and all of that things. So we have like a wonderful platform that is really, really great for us to, even deploy on a peer-to-peer network. So even if, for some reason, Netlify goes down, like unavailable, if you have it deployed on a peer-to-peer network using Spheron helps you to like, they kind of do some of these things behind the scene. They just give you access like a UI for you to import your code, and they handle the rest. They handle the rest in this case, they leverage on IPFX or Airwave to deploy your code, and it will be available peer-to-peer, like it's already on the network and it's already available there. So Spheron is like, it's like a very good platform for you to deploy your decentralized application and make it run on a peer-to-peer network, which is not the regular server that we have that we regularly use to run our front-end application. So, with that being said, I think with all of that, the blockchain space and Web3 is really excited to welcome you to a new dispensation. Thank you very much.
It's very important for Mara to host workshops like this because we have a lot of talents out there that are willing to get themselves into the Web3 space. It plays a major key in onboarding a lot of African talent into the Web3 space.
Follow us on our Telegram and Discord channels.